a square matrix where the entries that are off the main diagonal are all 0 is called a diagonal matrix. So here are other examples of diagonal matrices where all the off-diagonal entries are 0. And a diagonal matrix is invertible if and only if all of its diagonal entries are non-zero. So we can see that the inverse is easily computed, where we put the diagonal matrix and the identity matrix in an augmented matrix, and we aim to obtain 1s on the diagonal to reduce this to the identity matrix. So this is done by multiplying the second row by 1/3 and the third row by 1/2. So therefore what we obtain are 1s on the diagonal, and then this becomes 1/3 and this becomes 1/2. And therefore this matrix is the inverse of A. So if we had 0 on a diagonal, then we could not reduce A to an identity matrix, and therefore the inverse would not exist. So really think about this. Now the powers of a diagonal matrix are easy to calculate. So if n is a positive integer, so we effectively raise each diagonal element to the power of n. So we can see this by multiplying A with itself several times. So try to multiply these two matrices together, and you'll get 1 squared, 3 squared, and 2 squared on the main diagonal, with the off-diagonal elements being zeros. And if you keep repeating this n times, you'll get a to the power of n, where n is a positive integer.